Hello everybody, welcome back. Today we're going to finish up section 6.5 slope point form of an equation for a linear function. We're going to look at a word problem here. As the sum of the angles s degrees and a polynomial is a linear function of the number of sides n in a polygon. The sum of the angles in a triangle is 180 degrees. The sum of the angles in a quadrilateral is 360. Write a linear function represent this, equation represent this function. So what do we know here? We know that s is going to be equal to a function of its sides based on n number of sides, right? So that could be that for there. So 2 points on the graph have coordinates, we'll go with t for the triangle, right? And that would be given by 3, 180. So the number of sides, n, and s is going to give us the sum of the angles, as a function of its sides. So that means a triangle has 3 sides and they add up to 180. Okay? And next we'll go with the quadrilateral. We'll obviously call that one Q. And that has 4. And those sides add up to 360. Okay? We do actually do this in Math 11. We look at this equation again, actually. Okay? So, the number of angles depends on the number of sides, the sum of the angles. So that means that these 3 angles add up to 180, which you guys are aware. We did that in chapter 2 when you learned that in middle school. And then a polygon has 4 sides. So this is a quadrilateral. It has 4 sides. It adds up to 360. So it is a linear relationship it's telling us. So therefore we're able to create a function for this, all right? So our equation that we learned in the last video is y minus y1, x minus x1 is equal to y2 minus y1 over x2 minus x1, okay? So that's our equation, because remember, this is just slope and it's rearranged. So that's what we'll do is we'll recopy that formula and we'll start plugging in the values that we have. Okay, so I recopied our formula, and then we're going to start plugging stuff in. So remember, y is equal to s. That's the number of the sum of the angles, and n is the number of sides. So everywhere we see y, we'll put s. I should be doing that in the next one. It's no big deal. I'll just cut this out, bring this up, putting it the wrong one. N, and then s. N, S, N, right? So here we have S, or N, and then S. Okay, N is X and S is Y, so I substitute all those in. So the first one we'll use is the triangle. So S was equal to 180. N is equal to 3. The same ones go on the other side. And then we just plug in the 360, the second one, which is the quadrilateral, and that's 4. Okay? And we'll simplify. We get 180 in the numerator, we get 1 in the denominator. Okay? And we'll multiply both sides by n minus 3. Now, obviously, if that's over 1, we can just leave that as 180. Multiply both sides by n minus 3 because we want to get rid of that denominator. So multiply both sides by n minus 3. So you do to one side, you do to the other. These will divide out, giving you 1. That's why we did it. Let's clean it up. And we get s minus 180 is equal to 180 multiplied by n minus 3. And now we're going to solve. So what we'll do is we'll take the 180 multiplied by n and 3, and we get 180n minus 450, or sorry, 540. Add the 180 to both sides. So the 180, because it's minus, we add it to both sides. So we add that 180 over here. And when we do that, that gives us negative 360. So there's your formula. So the slope-intercept form, or the y equals mx plus b form, is equal to 180 multiplied by n subtract 360. So n can't be less than, there's a domain here, that n value can't be less than 3 actually, because there's no, like you can't have a polygon here with two sides, right? So there's a domain, n has to be greater than or equal to 3, and it has to be element of the whole numbers, right? Or integers, or natural numbers to be more specific. So there's your equation, okay? You gotta be careful there. Let's answer question B. Question B says, use the equation to determine the sum of the angles in a dodecagon. Dodecagon, I put in the brackets there. That actually has 12 sides, so that's your n value. So we just take our formula. Okay, take our formula, plug it in. So we know n is equal to 12. We put n in as 12. Multiply 12 by 180. We get 21. Sorry, folks. Sometimes this gets picky on me here. S equal to 12 multiplied by 180, that gives you 2160 minus 360. And then we subtract the two values. We get 1800. So that means the sum of a polygon with 12 sides, a dodecagon, is equal to 1800 degrees. Okay? So I'll write a little sentence to explain that. So the sum of the angles in a dodecagon is 1800 degrees. Let's check your understanding there. It's got to do with degrees Celsius and Fahrenheit. You can work through that. Let's look at example 4. So writing an equation line that is parallel or perpendicular to a given line. Right? So let's take a look at this one. Let's do the A part first. So remember, if it's parallel to this line, remember lines that have that are parallel have the same slope. Since the line is parallel, the slope is 2/3, and it passes through this point, right? What we can do is use the slope point form, because we have a point, we have the slope. So let's grab the formula slope point form. So we have the slope, we can fill that in as 2/3. We have a point, the point is at 1, -1, so that means y1 is -1, so we replace that with bracket -1. And the x is 1, so we replace the x1 with 1. Let's clean this up. And we get y plus 1. The 2/3 gets multiplied by both, so 2/3 x minus 2/3. minus 2/3. Oh, shouldn't have an x. I don't know why the x came there. Right, so the distributive property 2/3 x multiplied by, and then 2/3 multiplied by -1, and we get there. So now we're going to subtract the 1 from both sides. On the next line. So we subtract the 1 from both sides, it's gone, -1 over here. And of course, in order to add those together, or subtract them, that has to be changed to 3/3. We find a common denominator, and once we change that to 3/3, that becomes 5/3. So the equation of the line that passes through the point 1 and that is perpendicular is going to be y equal to 2/3 x minus 5/3. Okay? And again, you can leave it in either form here. Remember this here. This is slope point form, and then you can rearrange it. I just did that. I know it didn't say to do that, but you can. And then if it asks for slope intercept form, this is slope intercept form. Again, just going past what it asked for, but it's good practice, right? Okay, showing both forms. Next, what we will do is we will calculate so I just fixed it up. I went up one step with the slope point form, and then I rearranged for slope intercept form, right? Just going past what the question was, that would have been fine. Now, if the line is perpendicular to this line, then our slope obviously becomes a negative reciprocal, and then we do the same thing. So I'm going to just steal all this information because we're just going to change it a bit. All right. So if the slope is perpendicular, the slope is the negative reciprocal, which is -3/2. So instead of putting 2/3 in, we're going to put -3/2. All right. That would make that -3/2. So there's your slope point form, and you're done. I'm just going to take it a step further, and what we'll do is we'll put it in slope intercept form. So the -3/2, that's going to be times the -1, so it's going to be +3/2. Okay, we add the 1 to both sides, so we're going to clean this up a bit. So it'll be -3/2 x plus 3/2 minus 1. Subtract the 1 from both sides. All right, then you want to find a common denominator. Some people can just do the math. Like for me, it should be intuitive here, right? We can just subtract that. But I mean, if you need to show the work, that's fine. And we get -2/2. Find a common denominator. And then we subtract the 2, and then that obviously becomes 1/2. So there's your equation in slope intercept form. Okay? Slope intercept form. There's a check your understanding goes along with this. All right, you do the same thing that we just completed here. Okay? And then there's some homework questions as well. On page 32, numbers 5 through 14, 21, and 22. Okay? And that's it for this video. In the next video, what we'll do is we'll go to 6.6, and we'll look at the general form of an equation for a linear relation. So that's it for this particular video. If you have any questions at all, please ask, and we'll talk again soon.